I did not intend B to be sort of a trick question by leaving off the neither as an option or none of the above. I also didn't intend for 3 of the 4 standard matrices here to result in transformations that were neither injective nor surjective. Oops, but it shouldn't have mattered. We here had to remember that injections, right? This is when we talked about our columns being linearly independent, which is how we checked this back in the day, was with a reduced row echelon form of the matrix of our vectors, like right formed by those column vectors. And we wanted to see that the number of pivots equaled the number of columns. If it didn't, that meant that we had one column, whatever that column was, that ended up having our free variable that was linearly dependent on the others, or at least some of the others, right? And then for surjective or surjections, this is when our columns span our codomain. So we're looking for the number of pivots to equal the number of rows. And then bijection, we have both injectivity and surjectivity, so we end up with the identity matrix. This is similar to our, if we wanted to write about our columns, they would form the basis for our codomain. Anyways, this is where we're at. The very first one, we have our beautiful identity matrix. We have pivots in every row and every column. So the cleanest way to talk about this is to say, okay, this is a bijection. And we could just say something like the reduced row echelon form of A is equal to the identity matrix, right? We've done enough work at this point tying all these different ideas together that this is enough of an explanation for us. All right, 2 is none of the above. Right, it's neither injective nor surjective, and therefore it is not bijective either. In this case, we can see our number of pivots is equal to 2. Oh, 3, I can count. I didn't see that third little one. 1, 2, and 3. Well, our number of columns is equal to our number of rows. Looks like we're moving from R4 to R4, which is equal to 4. And since none of those things are equal, we don't have any of the stuff. We could talk about what is missing here. It's not injective because of one. It's not surjective because of the other. But we don't really have to talk about either of those in this case, because all I need to say is that my pivots don't match those two, right? We're at that point. Okay, moving on to the back, we had the same, I think I had some copy paste answers, which were completely lovely. So in this case, none, and we have only, we could write number of pivots does not equal the number of rows. It also does not equal the number of columns. In this case, our rows and columns are different, but we still only have 2 pivots to our 4 rows. We definitely aren't spanning in terms of those column vectors, which means we are not surjective. We can't hit everything in our space that we're moving to. In fact, if we think about this particular transformation, it would be moving from R3 to R4. Right? Think about how we would multiply if we did the matrix multiplication here. We need a vector that had an x, y, and z, and we would get out a 4D vector. So yeah. Anyways, and then our number of columns is only 3, but we know that that second column, we can even see it, is just a multiple of the first. So nothing exciting happening there. We don't have our independence, which means we're going to have multiple things, multiple pre-images in our domain that map to the same image in our codomain. All right, and then we move on. The last thing we have here, same, we could just write none. The number of pivots does not equal the number of columns. We only have 2 pivots for all 5 columns. It also doesn't equal our number of rows. Now, a lot of students, I think, because they were just so thrown off, they felt like they had to have an answer, like there was no way I would have left off the none of the above option or had 3 that were all the same. A lot of students on these last 2 told me that we had surjectivity, that we had as many pivots as we had rows. And I think those students who were just getting distracted by like, or conflating the idea of having a consistent system, right? If we have this row of zeros, this just means we have infinite solutions. Thinking about that, and therefore ending up in a space where they thought, okay, well, that's okay. It's fine to have a row of zeros. We just can't have an inconsistency, right, in our system. But in reality here, we need our 2 pivots for our 4 pivots for our 4 rows in either one of these last 2 questions in order to span R4, the place that we're headed towards our codomain, right? In order for our image to be the same as my codomain, to map to everything in that vector space.